All right, hello again. Today we're looking at solving problems with transversals. So again, we're looking at more relationships with transversals. More this time, looking at how do we use those relationships to solve problems. Let's take a look at three problems here that involve transversals, lines that intersect parallel lines. Here, in this example, we have a set of parallel lines, and this line that intersected is our transversal. All right. So now, in order to solve problems with transversals, we first need to be able to identify the relationship between our angles. So if we take a good look at this, here we have an x degree angle in this intersection. Then we have a 125 degree angle in this intersection. Also, another thing you might want to notice at this x degree angle, this is an exterior angle, and then the 125 degree angle, this is also another exterior angle. And both angles being interior, they are across from each other on the outside, which means they're crossing that transversal. So which means if they're exterior angles and they're across each other on the outside across the transversal, that means these two are alternate exterior angles. And what we know about alternate exterior angles, these angles are congruent or have equal measure. So that would mean that x degree angle is equal to 125 degrees. And therefore, our problem is solved. So x is equal to 125 degrees because the two angles are alternate exterior angles. All right, look at our next example. All right, here we have an x degree angle here, an 84 degree angle here. But one thing to notice about these two, that both of these are inside the two parallel lines, which makes your x degree angle an interior angle, and then the 84 degree angle is also an interior angle. So we're dealing with two interior angles, two angles on the inside. Now, here's our transversal here. All right, and these two are across from each other on the inside. They're across each other on the inside, which means that these two angles are alternate interior angles. And what we know about alternate interior angles is that alternate interior angles are congruent, which means they have the same measure. So that means our x degree angle will be equal to the 84 degree angle, and therefore our problem is solved. So x is equal to 84 degrees by way of the alternate interior angle relationship. All right, let's look at our last problem here. Here we have a 2x plus 1 degree angle and our 65 degree angle. All right, and here we're going to solve for x. Now remember, in order to solve the problem, we need to first identify the relationship. All right, so We know it's a 2x plus 1 degree angle is in this position, this intersection here, and the 65-degree angle is in the other intersection. But one thing you might want to notice here is that both angles are in the same position in both intersections. So if the two angles are in the same position in both intersections, that means that these are corresponding angles. Here's the corresponding angles, which means when we have parallel lines, our corresponding angles are equal. So that means that the 2x plus 1 degree angle is equal to the 65-degree angle. So now that we have these two equal, now I think we have an equation to solve. Taking this out of parentheses and solving this like a regular equation using inverse operations, subtracting 1 on both sides. Now I have 2x equals 65 minus 1 gives me 64. And now divide by 2. I get x equal to 32. And if you really check this, we can substitute 32 back into the equation. That's 2x plus 1 equals 65. And we're evaluating the equation for x equals 32. So that's 2 times 32 plus 1 equals 65. 2 times 32 is 64 equals 65. And 64 plus 1 is 65 equal to 65. And that is a check. So therefore, our solution is x will be equal to the value of 32. And also from my check, we also notice that both angles are indeed equal. And this will be proven by the corresponding angle relationship. And that's how we use angle relationships to solve problems involving transversals. Is first identify the relationship, and based on the relationship is how we proceed to solve the problem. All right.